welcome to the final lesson of Unit 7. And today we're going to write those quadratic functions. There's a couple of different ones. Sometimes we'll be given a vertex and a point. Sometimes we'll be given the x-intercepts and a leading coefficient. And other times x-intercepts and another point. And we're going to work with how to write them in the different forms that we are asking you to look at. Here we have writing the quadratic function given the vertex of 2, 0 and a point of 0, 3. And we want to write the function in vertex form. The first thing we're going to do is place the coordinates into vertex form. Remember, vertex form is going to be f of x equals a times x minus h squared plus k. And so we place those coordinates. We have our vertex, which is 2, 0. So that means I'm going to have minus 2 squared plus 0. And then we're going to place that point. Also, we have 0, 3, so that's 0 for x. We still have a, and then our y is 3. So we're going to solve for a now. We simplify this down. We've got 0 minus 2, which is negative 2 squared plus 0. And we got a equals 3. Well, plus 0, that cancels out. Negative 2 squared is 4 times a equals 3. And then we divide by 4. So we get a equal to 3/4. The last step then is to place a and the vertex back into vertex form. We no longer need the point, so we can go f of x or y, we're going to use f of x, equals our a value, which is 3/4. And then we replace x back in there, x minus our h of 2 squared plus 0. You can put it in if you want, not totally necessary. So there is our equation. F of x equals 3/4 times x minus 2 squared. The next type we got is quadratic function given x-intercepts of 4, 0 and negative 3, 0 and write the leading coefficient with negative 1. I want you to leave this one in factored form. This is what I call a classic plop and drop. So we find the binomials from the 0. If I have an x-intercept, x equals 4. Remember, I'm minus 4. So then I get my first binomial of x minus 4. And I have an x equals negative 3. I'm going to add 3. So I get my other binomial of x plus 3. And then my leading coefficient is negative 1. So the f of x out front. And this is my answer. Classic plop and drop. So we found those binomials. And then we placed a in front, and there you go. Final type. We're going to write the quadratic function given x-intercepts of negative 2, 0 and 7, 0 and a point on the graph of 5, 4. We're going to write this in factored form. So it's similar to the last one, but it kind of combines the two. Our first thing we're going to do is find the binomials from the zeros. So if I have x equals negative 2 and x equals 7, I'm going to minus 7 and add 2. So that means I get binomials of x plus 2 and x minus 7. And then my second step is going to be to place the coordinates for the point from into factored form for x and for y. So that means I know I have an a out front and a y. So now I replace those. And so my y is 4. I still don't know what a is. And then my x is 5, so 5 plus 2 and 5 minus 7. Place them in there. I'm going to solve for a. So 5 plus 2 is 7. 5 minus 7 is negative 2. And I got a. 7 times negative 2 is negative 14 times a equals 4. Divide both sides by negative 14. And that means that a is equal to over negative out front, 4 over 14, but I can simplify that to negative 2 over 7. So then my final step is going to be to place A along with the zeros back into factored form. So we've got my f of x, or y, and A is negative 2/7, and then I have x plus 2x minus 7 from up here. And this is my form. So now, what I need you to do is, as you guessed it, practice. We got these three. But first, write the quadratic function given the x-intercepts of negative 6, 0, and 1, 0 with leading coefficient of 2 in factored form. Then write the quadratic function given the vertex of negative 3, 5 and point negative 1, 3 in vertex form. And finally, write the quadratic function given the x-intercepts of negative 8, 0 and 4, 0 and a point on the graph of 2, 10, writing the function in factored form. And as always, bring your questions with you to class.